Chapter 28, Dimensioning. The learning objectives for this chapter are to create a variety of dimensions with the dim command, to be able to create linear dimensions, to be able to create dimensions that are continued or baseline dimensioning, to be able to work with radial dimensions, leaders, and quick dimensions, as well as to be able to apply GD&T symbols, geometric dimensioning and tolerancing, and some other methods for working with dimensions. So as we read through the textbook, the basic concept is that we create these drawings full size in model space. And then we dimension those drawings. And as we work with our dimensions, we want to go through some of the vocabulary. And so this is our dimension line, this is our dimension text, and this is what's called an extension line. And so if we use the dim command, we can place a linear dimension just by clicking on that line, and then the next click will show us where we would like that dimension to be placed. So for example, if I were to take a CAD drawing, and let's start with our mechanical here. And so here's our mechanical drawing, and we create the drawing in model space. And so here's the model space drawing, and I created some geometry off to the side here. And so we can work with our dimension command. We can use this automatic dimension maker, and we can select the dimension command. We select the line, and then we can place that dimension. When we place dimensions, we typically will place them on a dimension layer, and that way we can toggle them on and off if we're working with CNC or other computer-aided manufacturing. And so we can place the dimension by selecting the line geometry or the arc geometry as well. So this will give us our diameter dimension. Continuing. So as we place the dimensions, we can place the dimensions onto the part, and we try to locate them so that the drawing is easy to read. Dimensions are what's called associative, and there is a setting called dim associativity that allows us to update the size of the drawing if the dim associativity is enabled. So if we were to take a drawing and if we were to change it by stretching it, let's just stretch it 1 inch. What you'll notice is that the associativity updates the dimension to the new size. And that's called DIM AS SOC. And you can turn it off, although you do not want to. If you turn it off, then your dimensions will not update. And so we have some other dimensions which don't work as automatically as the dim command does, and that would be the dim linear. And so dim linear dimension would allow us to put a horizontal or a vertical dimension onto our component. And so we can go through, and depending on which side we choose, we'll be able to locate that dimension onto the part. We can add diameter dimensions as well, line dimensions. And this is an example of a baseline dimension. And so if we take a look at some of those examples, just erase this one here. We'll put our dimensions on our dimension line layer. And then here's our linear dimension, a line dimension, angular dimension. And if you hover over the commands, you'll get the help commands, which will show you the text placement. So if we start with a linear dimension, when we dimension, we want to have our object snap enabled because we want to accurately select those endpoints. And then if I go to the left, it'll be a vertical dimension. And if I locate it here, it'll be a horizontal dimension. Other dimension styles that we can use, like baseline and continuous dimensioning. We place a dimension, we'll use the Annotate tab, and then we can get additional dimension commands here, and you can pin this if you like. And then here's our dimensions, and so if we wanted a baseline dimension, the first dimension, let me escape out of that, first dimension and then our second dimension. It seems to be glitching on me here. So here we go. Here's our first dimension line and my second line. So to put in a baseline dimension, we'll start with a linear dimension, and then we choose baseline, and then it'll choose the next, and the next, and the next. And so that would be an example of a baseline dimensioning technique. Another would be a continuous, and we start off with a basic linear dimension. And then if we were to choose continuous, it'll continue the dimension. And it basically helps us keep the dimensions all neat and organized. Dimension spacing is the amount of spacing that they're placing the dimension. And it's really not a critical component because we can place our dimensions and space them just by clicking on them with grips. And so the preferred way is to place the dimension on the part, and then you can locate it. You want to avoid locating dimensions actually on the part. What about 5/8 of an inch, 3 to 5/8 of an inch off of the part, depending on how close it is. There is no specific rule, and if you go through an engineering graphics, they'll tell you, to have some spacing. But the ideal is that you'll use an endpoint. There should be a small gap here, which will automatically be created when you create that dimension. And then we just place that dimension. And so once we place a linear dimension onto the drawing, we can then place a grip on it, and we can edit that information. So we can move it, we could place it. Dimension angular will give us an angular dimension, and what we would do is choose two lines that are at an angle. And so if we take a look at our drawing here, if we wanted to know what the angular measurement was here, we would choose dimension angular, and then we select the two lines that make up the angular dimension. Depending on where you place the dimension, you can either get the 45 degrees or the 135, or the complements to that dimensional angle. We can dimension arcs and radiuses, diameters. When you create a diameter dimension, you'll get a diameter symbol for that. And so if we were to create a diameter dimension, choose dimension diameter, select the circular shape, and then place that on the drawing. One thing that I do often tell students to do on their drawings is to go to the Properties command and put the center marks on a separate layer. And so what I'll tell people to do is to disable the center mark. We'll still get the diameter dimension. And then what I recommend we do is we work on the center line layer on the Annotate tab, and we can use these center marks. And that way we maintain our standards, keeping the center lines on the center line layer and the dimensions on the dimension line layer. It's a small detail, but it does make the drawing easier to read by having different colors for the center line layer versus the dimension line layer. All right, continuing. Dimensional radiuses are just dimensional values for a radial arc. And that'll work pretty much the same as the diameter. Same thing with center marks. I'll often suppress the center marks after I've put those on there and put them on a separate layer. Here's our dim command, and we've done some work with that already. It automatically detects the type of geometry that we're working with, and then it will us to put that onto the drawing. And so if we're working with this arc here and we use an automatic dimension, we can go and select it there, and then we can select it here, and we can select it here. It will quickly put either linear or radial dimensions on there for us. Again, horizontal, vertical, and aligned dimensions we've talked about as we place those dimensions on. Aligned would be parallel, meaning it will give you the true length of that line. And then here's some additional information for our linear dimensions, angular dimensions. Ordinate dimensioning. They have some features that AutoCAD does very well, which is to make the drawing look easy to read. And so things like creating a jogged dimension line for something like a dimension which doesn't show the entire length. And so they'll draw this at full size 2 inches tall, but 16 inches to communicate this isn't really required. And so they'll put what they call a break line. And then when we break the object, then the dimension isn't going to be exact, and so we'll use a jog line to display what the true size of that dimension is. Dim center allows us to put the center mark in. So as we work with these different dimensions and these dimension styles, we can modify the dimensions just to make it easier to read. So if we use the dim break, what it will allow us to do is put a little bit of a break line without actually having to break the dimension. And these are somewhat advanced techniques as we start to go through. We just want to have the part to be manufacturable. As we look at other types of dimensions, we have leaders, and so we can use a leader to place note on something. And so if we were to look at our CAD system and we wanted to add a leader to it, here's our multi-leader command. We can select the leader command. I like to use nearest, and so I'll use shift right mouse click, nearest, and that way the arrowhead will make sure that it touches the geometry. And then I could say This is a multi-leader. And then the multi-leader styles and other aspects we'll talk about in the next chapter. But essentially it allows us to put a note. And then again, we can place this on the proper layer, keeping all our dimensions on the dimension layer. And so as we go into the leader and the design of the style for that, what they're talking about here is the leader settings. And so if we're working on a CAD drawing, we have these settings under annotation for dimension styles and multi-leader styles. And so if we were to want to make a change to this multi-leader style, let's say that we wanted it to be a spline, what we can do is we can select our multi-leader style, and then just like templates, it allows us to give a name for that, and then we can modify the settings. And so if I wanted a new multi-leader style, I could say, just call it multi-leader 2, and we'll continue. And then instead of having a straight line, I'll select it as a spline. And I'll say OK, I'll set that current, and I'll close it. Now when I create a multi-leader, I get the ability to have a spline type shape. And then we can just green check mark that. So it talks a little bit about the attachment, and we go into dimension styles a little more heavily in the next class for intermediate AutoCAD. But there's a number of settings that we can go through and we can change. We can change the arrowhead styles, we can change it to a spline, we can change the text values, different fonts, etc. You can add multiple leader arrowheads to the dimension style. You can add balloons and other things like that to our dimension style. This is an example of an ordinate dimension where we have the 0 location at the UCS 0 point. And this is great for designing for manufacture on CNC machines, because CNC machines are typically programmed with absolute coordinates, and sometimes you'll get called down to the shop where somebody will ask you to work out some of the coordinates, and so maybe this coordinate was missing from the drawing, and the machinist will ask the designer to calculate that coordinate for them. And so we can use an ordinal dimension, and that ordinal dimension would then give us an x coordinate 22.5 and a y coordinate of 12.5 as we place that on the drawing. And then quick dimensions allow us to quickly dimension our drawing. And so you can select quick dimension and select the object to dimension, and then when you right click you can kind of build these different geometries. So if we take a look at this exercise and we erase our existing dimensions, and then if we were to go with a quick dimension on here, what we can do is we can put a box around the geometry, hit enter, and then it'll quickly place the dimensions right there for the drawing. And so quick dimension is a very quick aspect to annotate the drawing and place dimensions on. And depending on how you format your dimensions, you can either have them set up for ordinal dimensions or linear dimensions. And so as we work with things like quick dimensioning, we select the geometry, hit enter, and then you can right click and you can then modify it. So we could say ordinal dimensions, and it'll place ordinal dimensions. And then we can add tolerances as well. And so as we progress through the course and get better at designing, we can start to create dimensions that have meanings like how much flatness or diameter relationships, tolerances, meaning how accurate that component needs to be. Things like maximum material conditions. And this is a somewhat advanced feature of CAD as we start to work on creating these drawings. To create a drawing with tolerances, what we would do is use the tolerance symbol. And so we can go to our Annotate tab in our dimensions, and then we can place tolerances on there. And so depending on how we set that up, we can then go through and place a GD&T symbol on our drawing. And that'll then communicate information about the drawing. Inspection dimensions we typically do not do so much work with, but again, you can add an inspection dimension. And then more information about working with dimensions and grips. And so as we work with these grips, we can do things like dial down the precision. And this is a common technique where we may have a dimension that's 2 inches, 0.000, and we want that to be 2.00. And so we can change the precision to be more forgiving or less critical. The more dimensional accuracy, the more zeros there are, the higher tolerances there are, and the dimension is more accurate. And then some other aspects of being able to flip the arrows and things like that. You want to try to avoid exploding dimensions, because what happens is it turns it just into regular line geometry. And then there's just some other commands for editing and modifying, but you can use grips just as easily to modify your dimensions. You can double click on your dimensions and you can edit the text. And so if we have a dimension and then we wanted to add a word like typical or something like that, you can double click on the dimension, right arrow, so that you don't erase the dimension. And you can edit the dimension in that manner. Again, we want to try to avoid exploding dimensions because they're no longer associative if they are exploded. And then they talk a little bit about some other variables and things like that. How to scale dimensions and the dim scale. And so dim scale is an important component, and it's different on mechanical drawings versus architectural drawings. And so when we look at an architectural drawing, and we work with our dimension scales, what we're working with is typically dimension scale that we will have set up in our Fit tab. And depending on how that dimension scale is set, for example, a 1/8 inch dim scale would be 96. Quarter-inch dim scale would be 48. And this is the inverse of the plot scale. There's another way to dimension called dimensioning to layout. But for example, if you create a dimension with a dim scale of 1 on an architectural drawing, it will be very small. And so if we went to create a dimension style of 1, and we made that current, and then we place that dimension on the drawing, it's going to be microscopic. It's going to be extremely small. It'll be accurate, but it will be very small. And so the technique is to be able to create the dimensions with the dim scale. And so if we go back into our dim scale, and I use 1/4 of an inch equals a foot, and I take a look at where that is, it's located right here in the Fit tab, and that would scale out to 48. And so when I put a dim scale with the 48, and I have to choose the correct dimension. And we'll get a much larger dimension style. That completes this chapter review.